Okay, this video is going to be how to find the sum of an arithmetic series. So that is adding up the terms of an arithmetic sequence. The first part we're going to do is a review of how to find any term in an arithmetic sequence. So we're going to go ahead and do that first. And that'll be part one of the video. And then part two will be adding up those terms that we found. So let's say we have the following sequence. Is it arithmetic? Yes, it's going up by 5. So we can make our table. We have it there, 1, 2, 3, 4, 5. We can go up to 100 and then eventually to n. And a sub n is, of course, the value of the term. So for term 1, we have 4. For term 2, we have 9. For term 3, we have 14. For term 4, we have 19. For term 5, we have 24, etc. And then to help us find 100 and n, we'll need to show our work. So we go ahead and make the column for work. And of course, we notice that the values of the terms of the sequence are going up by 5, which makes it an arithmetic sequence. So you continue in that way a bunch of times. Eventually, you'll get to 100, but we want to find a shortcut. So we go up to our work, and of course, the first term is 4. To get the second term, we did 4 plus 5. To get the third term, we do 4 plus 5 plus 5. And the fourth term, 4 plus 5 plus 5 plus 5. The fifth term, etc. So for 100, we know there's going to be a 4 plus a bunch of 5s, but we don't really know how many 5s. Well, up at the fourth term, there were 3 5s, so we did 4 plus 5 times 3. And for when n is 3, we do 4 plus 5 plus 5. 4 plus 5 times 2 is a shortcut for repeated addition. So we know that we can write a shortcut. We can write multiplication for when n equals 100 if we know how many 5s there are. And we know there are 99 because when n was 4, there were 3 5s. When n was 3, there were 2 5s. So there's one fewer 5 than the term number. That seems to be a theme for us. So 4 plus 5 times 99. And we could do the same thing for n. We know it's going to be 4 plus 5 times something, but what? Well, 1 less than the term number. The term number is n, so 1 less than that is n minus 1. So there we go. So our rule is a sub n equals 4 plus 5 times n minus 1. And that is part 1 of this video. Make sure you understand this before moving on to the next part, part 2, which is how to find the actual sum of the terms of the sequence. So if you need to stop here, rewatch this part, that's what you should do. If you feel like you have it and you can move on, then move on. But you're in charge of your own learning. Make sure you've learned this before moving on. So part 2. Well, what if we had to add up all those terms? So instead of 4, 9, 14, 19, 24, we're adding 4 plus 9, plus 14, plus 19, plus 24, and we keep going. Well, we can do the same thing, and we can set up a table. This time I wrote S sub n for sum instead of A sub n. A sub n is the term number. S sub n is the sum of the terms. So when there's only one term, the sum is obviously 4. When there are 2 terms, it's 4 plus 9, which is 13. Notice you don't see 13 anywhere up at the top because it's not one of our term numbers. It is the sum of the first 2 terms. And then to get the third one, we have to add the next term, which is 14. So 13 plus 14 is 27. Then add the next one. 27 plus 19 is 46. Then add the next one. 46 plus 24 is 70. And we could try to keep on doing that up to 100. But once again, going one step at a time, it's going to take us forever to get there. So we can show our work. And we notice that, wait a minute, this is just what I originally had up at the top. This table was for nothing. That's fine. If you don't need to make the table for this one, don't do it. But I always find it helpful, and I always like to make the connection. Whenever we're trying to find a rule, a table can always help us. So for the sum of the first 5 terms, we have 4 plus 9 plus 14 plus 19 plus 24, which is what we had at the top. So what if we want to keep going and do it for 100? Well, the beginning is going to be the same. We're going to keep adding 4 plus 9 plus 14 plus 19 plus 24, and it's going to keep going until it stops. When is it going to stop? Well, it's going to stop after 100 terms because we're trying to add together the first 100 terms here. So look up here. There we stopped at the 5th term, which was 24. And the one above that, we stopped at the 4th term, which was 19. The one above that, the 3rd term, which was 14. Right? So for this one here, we're looking for the 100th term. Well, where can I find that? I can find that back in the last table. The 100th term was 4 plus 5 times 99, which if we actually do 4 plus 5 times 99, 5 times 99 is 500 minus 5 is 495, plus 4 is 499. So we know that the 100th term is 499. So that's where we're going to stop. But that doesn't mean we're finished, because we're looking for the sum of 4 plus 9 plus 14 plus 19 all the way up to 499. How do we do that? Well, let's look at when n is 4. See if we can find a shortcut. So we have 4 plus 9 plus 14 plus 19. We could go ahead and add that up straight ahead. In fact, we already know the answer is 46. But what if we did it a different way? What if we paired them up? Well, we know that in an arithmetic sequence, the growth is constant. It goes up by the same amount. So we can go ahead and pair them up, and the sums are going to be the same for every pair as long as we pair them up in the right way. So 4 plus 19 is not 25. 4 plus 19 is 23. 19 plus 14 is 23. So we have two 23s. So a shortcut is to do 23 times 2, which of course is 46. And we already knew that. We already had that answer. But we found a different way to do that that might help us get to 100. So if we go to 100 now, 4 plus 9 plus 14 all the way up to 499, we can do it. What term came before 499? Well, 494, because that's 5 less. And the sequence was going up by 5. So 503. 4 plus 499 is 503. 9 plus 494 is 503. And you could keep doing that until you had no numbers left to add. So that gets us to 503 times something. Times what? Times however many 503s there are. Do we know how many 503s there are? Not yet, but we can figure. So how many pairs do we have? Well, let's look back up at the example for when n was 4, and we were trying to find the sum of the first 4 sequences. We had 1, 2, 3, 4 numbers that we were trying to add together. Well, but then we paired them up, so that meant we had 2 23s, 2 pairs of numbers. When we have 4 numbers and we pair them up, well, we only have 2 pairs now. And we can do that same thing down here. We had 100 numbers, but we're pairing them up, which means that we have 50 pairs. So there are 50 503s. So 503 plus 503 plus 503 50 times is 503 times 50, which is 25,150. I used my calculator. I didn't have to use my calculator. You can do it without a calculator. But I'm in a hurry, so I used my calculator. Okay, so that's our answer. You can stop right here. This is it. I'm going to show you how to write that using summation notation, which we learned the other day. So sigma, which means sum, we're adding up from 1 to 100. Well, what are we adding up? We're adding up the terms of a sequence, but we have to say what sequence it is. Well, the sequence is just the direct rule of the sequence. So that would be 4 plus 5 times n minus 1. So the sum from 1 to 100 of the sequence 4 plus 5 times n minus 1 is 25,150, which we just found. That's the sum of the first 100 terms of that arithmetic sequence. And that's it. We're done. Congratulations. Write it down, take notes, learn it. It's not easy. It's not supposed to be easy. If it were easy, you wouldn't need to go to school for it. So get the practice you need, come in for help, do what you need to do to learn this. The notation, I don't really care that much. I mean, I want you to learn it, but what's important is this sort of thinking that's happening here to make sure that you can add up a bunch of numbers when there's a pattern that's going to them. The end.